Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to my DIY Metal Router 2. So we're on, I believe it's episode 9 here. And so we've done almost 4 episodes tonight or so. And I just wanted to clean this up because, again, tomorrow is my last day in San Jose for a week because I'm shipping out Saturday to Hawaii, Maui, and I'll be back next Saturday. And tomorrow I wanted to do a video, focus on a video for the Green Engineers to kind of update everybody. But I wanted to, and then do a few more videos on this because I wanted to get this pretty much completed. So when I'm in Hawaii, I could be looking for lasers and also buy parts for this guy because it's looking like we're really, really close. So in this guy, what we're going to do after this 30 minutes is going to be 12 o'clock midnight. So then get ready for bed, etc. So let's go ahead and finish this guy up. So we'll finish a lot of it. Some of it will have to continue later on. I'm probably going to increase this to double this so it doesn't bend. Keeps it inside the cut. So we're going to put one here, one here. So we're going to have 4 rails here with the regular HG20CA block, and then we're going to put double here. Double 20 HGR 20, so 2 blocks here, 2 blocks here, and then that should be incredibly rigid, and we'll increase it to about 100 pounds. And right now what we're going to do is we're going to delete this one and delete this one, and we're going to design the clamp. So now the clamp, obviously the maximum here that we need to have is from this level here to this level here. Where'd it go? And that is 10 and an eighth. 10 and an eighth inches. So let's go ahead and start a new one. Let's create. So we don't really need much. So we're just going to go here top. And then this is going to be, we're going to do the 65 millimeter. And then what we're going to do is we're going to slit it so we could clamp it. So let's go ahead and let's add an offset of a 1/16. Plus 0.0625 inches, just a little bit bigger, 1/16 of an inch, so that's a 32nd on each side. So if we machine it really well, but again, this is going to be 10 inches tall, so probably machine this. I mean, that's pretty big. You're going to machine it all the way down, but again, this will also form a pretty good heat sink because it will be 6061 aluminum, and it'll heat sink it to here, and then heat sink it to, it'll have a big mass around here, and then heat sink it to the rails. So let's do that, and then let's go ahead and go in here and let's create offset. So here, offset total. Obviously, we do not want to pass this other number here, which is the length of the carriage, which again is this overall length right here from here to here. Oh, and then everything, I'll probably take off the grease fittings. And I'll just put them on when I need them because they're going to hit on one side. I'm going to lose something on one side anyway, so I probably should take them off. Okay, so down here, they're not really that big of an issue. I mean, it's going to hit the back wall over here. On one side, but I think that side will be behind this gantry anyway, so it's not really that big of a deal either there. Okay, so let's put, but these are going to be used a lot, so probably once a month I'll have to stick the grease fittings on there and redo it again and grease them. Okay, so overall length for the 20CA is 77.5. So we cannot go over that. So this distance from here to here. So let's go ahead and do that. This distance from here to there is 70, let's just do 75 millimeters. Okay, so what do we have here?
Again, this doesn't have to be big because it's going to be super... Okay, so it's a little over 1/8 of an inch. That's going to be fine because this thing's going to be like, what was it, 10 and 1/8 long. So that's fine. And also it's going to have a flat section here. Oops, so we need to make the flat section here. And there we go. So that's a flat section, and then we'll have a hole here, basically, kind of just a slight flat section down here that will put these bolts in. And so that is C. So let's go ahead and do that now so we could draw it later. So basically what we're going to do is we're going to go here, and then basically we want B divided by 2. So B is 32 divided by 2. 32 millimeters divided by 2. So yeah, that's this. B. So there's going to be a small little flat section there. 32 millimeters divided by 2. Okay, so now that's going to be a small little flat section. And so we're going to go up, but it's going to be bigger than that. So I'm going to say at least, oh, but it's not B, it's actually C. Okay, so we only need to do C. So C, because the rail's like this, so it's actually just C. So C is way smaller. C is, well, it depends on which rail. We're using the 20CA, which is 36. And obviously it needs to be bigger than that because these holes are 5 millimeters, so we're going to say like 7, 8, maybe round up to 10. So half, about 5 plus 5, so yeah, 10. So 22 plus 10. So that's 32. So this should be okay. And let's go ahead and do this, 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 and this. So it's going to be a small little flat section. Obviously, we can't make the walls around the wall square, so there'll be a fillet there. But the issue is that that's really, really far down. But we only need it in certain sections. So we only need it at the top. We only need it at the top small section. So we could use a small end mill here and then hog everything else out. So let's go ahead and, so I'm definitely going to need my XBoss to help me out with this here. So this is only going to be the width of the block, which is 44 millimeters. Oh, we can't do this because we need the Z. Completely forgot about the Z. So we need some sort of Z control. So we need some sort of up and down Z control here. And I don't think it's going to fit on 77. It's only 3 inches wide. This rail is. The rail is 20 millimeters wide. Oh, that's only 3/4 of an inch. So I mean, technically, oh, but then we need the width of the rails. The rails have to be next to each other. I mean, the carriages. So what's the width of the carriage? Yeah. This is 3.5, right? No, it's just 3. So yeah, 2 carriages won't fit on that. Only one is sketchy. Oh, but we'll have another one over here. So, I mean, we do have a lot. I mean, but we don't have a lot here. But we have a moment arm down there, which is just as much as if it was over here. So we should be okay by just putting one of these guys, one of these blocks, which are... Oopsies. 1.732. Okay, so let's hold on this for now. And again, also, this thing doesn't need to be as big as I was thinking there because we have the Z. The Z is going to be the big guy. So let's go ahead and look at this. So we're going to do the same rail again. So we're going to have a custom length rail that's going to go from here to here, which is 10.5 inches. So let's go ahead and duplicate, copy, paste. Let's go ahead and look at this one again. I think it's this one. Yeah, 1142. Yeah, so that's right. First off, let's rename. And let's just get rid of this for right now. Just so we can kind of tell. And then this is going to be 10 1/8. Oops. Actually, it's going to be, let's get exact measurements here. Yeah, 10.129. Okay, so this is, let's rename this. Ooh. Well, that's okay, because we could. So we could have it mounted. So we'll mount it on the bottom. So this guy will go on the bottom because that's where we need the most and not as much on the top. We'll have a bolt open on the top and just go here or something. Or we could always drill another one. Okay, so now we got that. Now let's go ahead and design the plate, which is on top of the regular HD20. And we're going to want, we could put 2 of those on there. And we want a total travel. Cat's looking through the window here. Alright, so we want a total travel. This is 5.5 inches minus about an inch, about a half an inch for the end mill. Let's say half an inch minimum for the end mill. And then most material is going to be at least 1/8 of an inch. So let's say, well, let's just say 5 inches of travel for right now. So what is 5 inches of travel? So this is total of 10. So can we 10? We want 5 inches of travel, so that's we need 5 inches of movement. And these things are how long? I mean, we could do one. And then obviously we're going to have one on the other side. So this is 77. 77.5, 77.5. It's 3 inches. Yeah, so not enough for 2.
That's 6 inches, so it'll need to be 11. So unless we have this guy counter this off a little bit, then we can't put 2. But I would like to do that just for the rigidity. So we might have it stick out a little bit. Well, it's going to have a plate underneath it, but the other issue with this again is with the grease, but we could have one grease going up, one grease going down. Not a problem. So 3, 6, 5, 11. So let's make this actually 11.5. We'll figure it out more later. 11.5 inches. Alright, so now we get a full bolt here. Good deal. And then this is about where it ends. Pretty close. Alright, so I like that. Let's go ahead and save that. Alright, so now the plate obviously is going to be, let's just go on top here. It's going to be as long as these. I mean, it doesn't even have to be as long as these. It just has to sit on here. Because any longer it doesn't really do anything. So L1 on those is 50.5. So let's just do 50. $50 Oops. The cap lock's on. Oops. And then this is going to have to be at least, what, 10.5. Okay. And then remember, the thicker this goes, the harder it is to, the more we lose. And again, it's pretty supported, so I think 1/4 inch aluminum should be fine. 1/4 inch plate should be fine. And let's change the body style of this guy to physical material. Aluminum 6061. Boom, boom, boom. Boom. And then this is Z-axis plate. What do you call it? Z-axis gantry plate. Okay. So there's a Z-axis gantry plate. Now let's go ahead and do the holes here. So at the top here we have W. So let's go ahead and draw a line from the top. Well, we don't really need to, but so now we need W, which is, or C. It's going sideways, so we just need C here. C divided by 2, which is 36 divided by 2, which is 18. 18 mm that way, and 18 mm that way. Okay. Which that's correct, right? Yeah, that's correct. And then this, we're going to have B1 from the top, which is 6 mm. So that's the actual point right there. Point. And then this is also 6 mm, 6 mm. And then B, which is 32 for the next set down, 32 mm. This one also down, 32 mm. Alright, so now C split, that's good. And there, and then point here, 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 here. Okay. Oops, so now let's do the same deal. We'll do the standard mirror procedure. Mirror lines, open origin, pick that mirror line, close origin again, object, 1, 2, 3, 4, and OK. And now these guys, we want clearance. I think they're M5s, so let's say 6 mm or something, just to help a little bit with location.
So let's go and create a hole here, 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 here. This is 6 millimeter, and through all. Okay. And it's just going to go through and bolt in. But we have a little bit of space there, but that should... Oh, and another thing, this is going to be extra long, so we can't actually mirror it. That's a good point. We can't actually mirror it. Okay. So from here all the way down is 10.1. From there we have to do the same deal. So basically what we're going to do is just go halfway from there to there, where it shows it. That's halfway. And that's our mirror line. And mirror. Boom, 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 boom. Mirror line here. And there we go. Does that look the same? Oops. .36, that's exactly right. Okay, good deal. There it is. Alright, so now we're going to create a hole. Why did I delete the hole? Strange. It looks like it's already set to 6 millimeters, so that's fine. Let's go ahead and save. Alright, so let's go ahead and go to General Assembly. Let's drop this in. Z gantry plate, drop it in. And again, if we can make this 1/2 inch a little bigger, then we'll do that. 1/4 inch, I mean, we'll make it thicker. Because again, we don't have that big of an issue with this is flipped. Okay, so it wants the other. Oops. What the heck? Why is it doing that? That's not the hole I told you to. Oh. There we go. There we go. There we go. There we go. Well, yeah, so they're not perfectly aligned, but I just kind of eyeballed them with the drive, so that's fine. Oh, and then we need obviously the all of the dimensions there. So we're gonna do another one here, and it's 20 and then 60. 20 here. Oh, but let's do it from the bottom, because we want it. This is where we're gonna do the most stresses. 20 millimeter, and we're gonna put a point there. And then we're going to do 60 millimeter every other one, 60 millimeter. And then we're going to put a point. And then we're going to do rectangular pattern. We're going to do this object and this object. And then we're going to do one direction spacing, 60 millimeters. So obviously that's the wrong way. Let's do 0. This is 16 millimeters. Let's see how many we could put. Looks like 4. Yep, exactly 4. Perfectly. Okay, good deal. So let's go ahead and stop it, assemble, create a hole. Boom, 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 boom. And then this now is small d, so let's just make it 6 millimeters for right now, which is already is. So let's just punch those holes in it. Save. Back to General Assembly. Update. Oh, 25 minutes already. Jeez. And let's drop in the 11.5. Wait, did I make this 10.5? What was the Z plate? Oh, yeah, that's 11.5. There you go. Okay, now it should be okay. It should still be okay because we said everything. Okay, there we go. Alright, so this guy's going from the bottom. So let's go ahead and mount this guy. Oops. With that guy. Oops, wrong side. Oh, I think I picked the wrong side. Where's the rail? There it is. There we go. That looks better. Sweet. Alright, cool. So now we could have 2 blocks on there. And that looks pretty good. Why is everything still doing that? I already did the joint. Why are you doing this? Component 1, what is component 1? Okay, so there it is. And then let's go ahead and drop a block in. We're going to do 2 blocks. As usual, and one will be with the thing facing up, one will be facing down. You get the idea. Let's go ahead and go off of this. Perfect. Perfect. Move joint down. There, that's fine. Okay. Then we're going to do the old school drawing. Project this one. Okay, and then this has got to be 30 millimeters here. Obviously, at this point, I mean, I would probably just make an assembly because I've made so many of these already at this point. But 3.92, 3 minus 3.92. Now this should be minus 3.92. Enter. Okay, good deal. So now when I look at this guy, it should be 3. Yep. All right, now let's do one more. Let's drop one more in. looking at 29. We'll just finish this, and then next video we'll have to do the block. I mean the actual what's it called itself? The clamp. What? Yeah, that looks good. So it's rotating, right? So let's go ahead and get this up on there. Let's go ahead. I think it's the same deal. It should be the same deal. Project include. Boom, boom. Drawing. Yeah, 3.92. Minus 3. So it's going to be plus 3.92 in. There we go. Alright, change everything back to inches. Still, we're going to hide these new sketches. Hide. Everything looks nice and clean. Let's go ahead and save. And then what I'm going to actually do is I'm just going to drive this last one up really, really close. This last slider drive joint. I'm going to drive it up really, really close to this other one. You can see they're kind of misaligned. I don't know why they're misaligned. But anyways, so yeah, I mean, before I kind of order all this stuff, obviously before I cut it, I'm going to make sure that everything lines up in the CAD, because obviously this is not going to work. So basically what that means is that this is not exactly in the center. And so that means that this other length is off. So that's not good. So obviously Z plate's in, so now the clamp will go here. And this guy is about 6 inches long, which is pretty much with this guy, I think, what is this length here? So overall length is 6 inches long. Well, not overall length, I'm talking about the clamping length that we have. It's about 7 inches, so it's almost the entire thing. So we're almost clamping on the entire thing. All right, so we're at 33 minutes. So let's go ahead and make sure everything's deselected here, and let's check our properties again. All right, now we're at 1,366. We're not quite at 100 pounds yet. Obviously when we get 1,600 ounces, there's 16 ounces a pound, right? Yeah, 16 ounces a pound. So obviously we need a second one here, and we need another 2 rails here, and then maybe another two of these also. So we're definitely gonna hit that 100 pounds, and this is gonna be incredibly stiff. So obviously we need to do this over again. I might do that off screen. I might just duplicate this off screen because, you know, while I'm relaxing or playing video games or whatever. Because, I mean, we already did it once. We do it a second time, you do the exact same thing over again. And then I'll show you guys kind of the fallout from that, which is basically going to be the clearance between here and there. So right here we don't even have a clamp yet. And we're already at 4 inches. So 65 millimeters is only 2.6 inches. So not too bad. But you have to think, that we need to lose this distance also. So 2.6. So let's do this last calc before we hit the sack here. Get ready to hit the sack at least. So 2.612. Well, the total. Let me see. Do I have a pen? Oh, I do have a Make magazine pen, and I do have I have a little Make magazine booklet. I need to figure out where my maker book is in my backpack. Oh, it's got the little thing on top to protect the pen. Let's go throw that away. So this is 2.612 to rail. So yeah, at the previous Maker Faire last year, they gave me a little notepad, it looks like. So that's pretty cool. And then from here to here, this is 4.888. So 4.888 minus 2.612. Just because it's late at night, I don't want to make any mistakes. 2.612 is equal to 2.276, and that's obviously without any thickness on the clamp on either side. And 65 millimeters is 2.559. So we're definitely going to have to make this wider. So right now we're at, what, like 7.5 inches. So we're going to have to be almost like maybe 8 or 9 inches. And then that will be super rigid. We'll increase the weight a little bit. Obviously, weight is good. Increase our cutting strength and also lower vibrations. So I think we'll be able to hit 100 pounds, but after that we're probably just adding weight for the sake of adding weight and not really increasing strength. Of course, we're going to have a T-slot table here, and also a fixture plate down here, and then also have material on the plate, and also have a fourth axis down. So we're going to have a lot of other stuff down there. So, so far, so good. Alright, so this has been Steven from Legit Tech Tutorials in the Green Engineers. I thank you guys for watching. If you like this video, please subscribe for more videos like it in the future, and I'll see you guys in the next video. Thanks for watching. Take it easy. Peace.